Welcome to day 8 of our challenge. Today we're going to focus on how to perform statistical tests with complex survey data. But let's take a step back and answer the question, why do we perform statistical tests? Well, the answer is for the same reason we perform tests in any other context. For example, let's say you're in school. Why are you giving a test during the course of a term or semester? Well, it's to answer the question, did the education that was imparted to you make a difference? Did you learn? And so the test aims to assess whether there was a difference in your education or in your processing of information. That's the exact same thing we do when we administer statistical tests. The question we're trying to answer is there a difference? That is always the question we're trying to answer. Is there a difference? Now, the answer we get could be classified into two main possible options. We can get the whole truth, which is the truth with holes, or we can get the whole truth, which is the truth without holes. Remember that epidemiology is the science of truth, chance, or bias. That's all we study in epidemiology. And our goal really, hopefully, is to get to the whole truth. But sometimes we are stuck with the whole truth, which is the truth with holes. And those holes means that our study is still subject to chance or bias. And those pose a threat to internal validity. Now, let's return back to the issue of tests. When we do bivariate tests, like chi-square tests or two-sample t-tests, or any of those bivariate tests, this is what we are getting. We're getting the whole truth. And that is because we are looking at crude relationships between two variables. So there's still a lot of alternative explanations for what we have observed. However, when we want to get the whole truth, this is when we choose to use things like multivariable analysis or regression. So it's very important to understand why we do certain things during analysis. The goal here is to make sure that we eliminate, to the extent possible, the role of chance or bias. Now, let's go to our tasks for today and let us go through them so that it can consolidate our understanding of both bivariate tests and regression within the context of statistical testing with complex survey data. All right, so the first subtask says, without checking any external resource, what tests do you think is appropriate to assess whether cigar smoking prevalence differs by disability status? All right, let's go to the Chisquares platform and let us see how we can determine the appropriate test to use. That addresses the second part of the question here that says, now check this with a statistical test checker under the analysis wizard. The issue we're trying to address here is that most people struggle with the kind of test to use. Some people carry around a cheat sheet that says, oh, if you have this variable and that variable, use this kind of test. Well, on the Chisquares platform, that has been addressed, so you don't have to memorize tests like that. So let's see how we can know the kind of tests we need to do in this particular situation. We have current cigar and any disability. So go to the Chisquares platform. Our project is already loaded, and we'll come to the analysis wizard. The analysis wizard is really your friend if you're not really sure of what you're doing. And so there are lots of resources here to guide you in whatever it is you might be trying to achieve. So in this case, we want to go to the statistical test checker, and we will select the two variables we're interested in. In this case, we have current cigar. So let's select that. Current cigar. And we have any disability. Right here. And so you select the two variables that are involved in the bivariate test. A bivariate test will always have two variables. That's why it's called bi. Bi means two. And then you click on run. So the platform takes that information, checks through a decision tree, and then it will then provide you with the appropriate test. So it doesn't matter whatever variables you select here. There could be any two variables at all. The platform will still execute the same thing. So in this case here, the platform tells us that The appropriate test will be a chi-square test of independence. It provides the justification for us. It then performs the test and gives us the test results, interprets the results, and gives us the table here. And so that's how you can determine the kind of test you need to run. You don't have to memorize it. You can just use the test checker on the Chisquares platform. If you wish to subset the analysis to a subgroup, then you can click this button that says run among population subsets, and then you can define the subset accordingly. All right, let's go back to our questions. So this finishes subtask 1. Subtask 2 says you're interested in comparing the number of cigarettes smoked in the past 30 days. This is a count variable. In the data set, it's called total cigs 30. And our objective is to see whether the total number of cigarettes smoked in the past 30 days differs significantly between daily smokers and non-daily smokers. Now, we want to get to the whole truth, not just the whole truth. So what we need to do is to make sure that we control for other confounders. A confounder is a noise maker. Imagine you're in a room with your guests and you're having a very serious conversation. And upstairs you have an extremely noisy neighbor. And the noise level is so much that it's very hard for you to focus on what your visitor or your guest is saying. That's exactly how confounders behave. So in this illustration, you and your guest represent your exposure and the outcome. We are trying to measure the true relationship between the exposure and the outcome. So it's as though the exposure and the outcome are having a discussion. But we have the nuisance variable, which is literally what we call them in epidemiology, making a lot of noise in the background. So for us to be able to measure that relationship perfectly, we need to control for that confounder. So in this case, we're trying to see whether there's an association between the frequency of cigarette smoking and total number of cigarettes smoked in the past 30 days. But of course, there are confounders we need to worry about. So what this question is saying is that you should measure that relationship, but it should account for all those confounders. Another way of saying this is that we should use a regression model to answer that question. So unlike that subtask number 1, where we just use a bivariate test, specifically a chi-square test, here the task is saying that we should use a regression model and we should take care of this noisy neighbor by controlling for it. So that's what we're going to do. So the task here says that we should control for the confounding effect of trade or type of occupation, the gender, the race, age, education, and poverty levels. And we have specific action items under this subtask. There are 5 of them. The first one says we should first replace the variable total 630 as missing if the individual is not a current cigarette smoker. So if you recall, the way we created this variable was such that individuals who are non-smokers have a value of 0, but they should have a value of missing. So let's go ahead and replace that. So we'll go to the Chisquares platform. We would search for our variable 6. Let me check the name again. Total 630. All right. So, all right, here's the variable. To replace the values with missing if an individual is not a current cigarette smoker, we would select these 3 options here and select replace. And we want to replace not the entire column, but just a subset. So we're going to select subset here, and we'll define the subset as defined by cigarette smoking, current cigarettes. So this is our current cigarette variable. We select it and click on done selecting. So if value of current cigarette is exactly equal to 0, so if they are a non-cigarette smoker, then that replacement is supposed to occur within that subset. So This is the variable we are searching. This is the subgroup or the subset of a population in which the action is supposed to take place. The value we are supposed to find is anything. Find anything in that column and replace it with missing. And we replace. All right. So we have successfully replaced that. And so the whole reason why we're doing that is to prevent an overinflation of zeros. So we want the zeros to be legitimate values. So in this case, individuals who are non-cigarette smokers obviously have a zero, but we want to replace it with missing because they're not part of the population of interest. Next, action number 2 says, are you 100% sure of the appropriate regression model you should use? So in other words, if you are not sure, you should verify. So let's see how we can do that on the Chisquares platform. Let's go back to the analysis wizard. The last time we used the statistical test checker. This time we will be using the regression analysis checker. So we click that. We select the outcome we're interested in, which is this total number of cigarettes smoked in the past 30 days. And we'll select the type of variable it is, which is a count variable. So click that. Then the next question says, choose whether the outcome was measured one time or multiple times. This data came from a cross-sectional survey. So we're going to select cross-sectional. And these advanced options do not apply. So we're going to click on run. All right. So here, the platform has suggested that in this case, the recommended regression model for our variable here is a negative binomial regression model. So in this case, that fits this perfectly because this is the count data. Now, some people have the idea that whenever you have count data, then you should use Poisson. Well, that is not technically true. Poisson model has a very stringent set of assumptions. One of the assumptions is that there is equal, the ratio of the variance to the mean is about the same. So we call that equidispersion. But in cases where there is drastic variation in the outcome, as you can imagine, number of cigarettes smoked per day would vary dramatically. And so a Poisson regression model might not be the best choice. So when you run a regression analysis checker, the platform checks the underlying assumptions for the different candidate options. And if an option is violated in terms of its assumption, the platform will not select it. So in this case, it has done all the underlying checks for us, and it has decided that the best regression that we could use would be this. And so that answers the question of this action 2. Now we know that the appropriate regression analysis we're supposed to perform with that variable is a negative binomial regression model. All right, let's go to action 3. It says we should recode the smoke cigarette variable so that we can understand what it means. It's always a bad idea to keep values of 1 and 2 and keep trying to remember what they mean. So to keep things very clear, let's recode a variable such that value of 1 represents daily, value of 2 represents non-daily, and all the others are kept as missing. So we'll head over and we will select our variable smoke sig. This is it right here. We would click the 3 dots and click on recode. So 1 is supposed to be daily. 2 is non-daily. And all the others are to be set to missing, because our study population in this case are individuals who are current cigarette smokers. The rest are not part of our study population. So we're going to select all, uncheck these ones, and mark as missing. And let's call this variable smoke frequency. Okay, so we have generated that variable as required. Let's visualize it quickly. All right. Next question says, fit a negative binomial regression model with total cigarettes in the past 30 days as the outcome. Then we're supposed to choose the following as predictors: the smoke frequency, which is the variable we just created, age, gender, race, education, trade, and poverty as predictors. Now let's do that. So we will go over here to estimate and regression analysis. We'll select the appropriate regression. In this case, we are going to select negative binomial regression. The outcome variable is total number of cigarettes smoked in the past 30 days. And our predictor variables are smoke frequency. We have your trade. We have poverty index ratio, education, race, age, and gender. Those were the variables that were provided in the instructions. So done selecting. So when you select your predictors, the platform automatically selects a reference group. A reference group in regression is the group that the results, all the other groups will be compared to. You can think of it like the general that is leading that variable into battle. That's a simple way of thinking about it. But every other group will be compared to that group. So for example, in this category of trade or occupation, we have trade logistics selected as a reference group. The platform makes its selection based purely on sample sizes. So it picks the group with the largest sample size and selects it by default as a reference category, but you can obviously change this to whatever else you wish to use. For example, I might want to use individuals who are in the health profession as the reference group. But again, I'm going to just leave it the way it is. This is just for a demonstration. And then now we can check for model optimization. If there's collinearity, we can check for all of those things here. But I'll just go ahead and run my model right now. So the platform then takes that information that we've provided. Again, remember that our dataset info reveals that this is weighted. So the analysis are going to account for the complex survey design, including the weight variable, the PSU variable, and the stratum variable, such that the analysis produce valid estimates. So here we have our results. These are the variables. These are the comparison groups. For each result, you have the results being compared to the reference group that we had selected. And these are the coefficients in terms of, in this case, incidence rate ratios. The Poisson regression models and negative binomial regressions both yield incidence rate ratios. And here are the p-values. The platform also generates a plot because, well, a picture is worth 1,000 words, they say. And so you can review the figure to see the relationships in question. There's also the text, which is the platform writes out the results for you so that you can understand the context or the interpretation of the results clearly, so you don't end up misinterpreting the results mistakenly. And then there's metadata. If we want to remind ourselves of the context, we can check to verify that indeed the analysis were weighted. So in this case, the analysis was negative binomial, and we have weighting. Yes, weighting is true here. So that's how you fit a regression model on a platform. Then action number 5 says we should review the text generated, which is this part here. Review the text and the figure and try to make sense of it, try to understand what the results are saying. So that's how we perform statistical testing on weighted data. I look forward to reviewing your answers and your reflections to the questions. The data set is the same as the one we've been using from days 5 to the present. If you have any questions, please drop them on LinkedIn and I'll be happy to answer. Thank you.